Hi, today we are continuing the parameterized curve portions. Next is what do you mean by a cycloid? The parametric coordinates for these cycloid is x is equal to a cos theta, a into theta minus sine theta, y equal to a into 1 minus cos theta, right? And this minus infinity less than theta less than infinity. This is a cycloid notation actually, right? How does it works? This is actually the cycloid rotation. Take a coin. Okay, 1 rupee coin choose ചെയ്യുക. ഒരു പോയിന്റ് അതിൻ്റെ എൻഡിൽ റെപ്രസെന്റ് ചെയ്യുക, ഫിക്സ് ചെയ്യുക. എന്നിട്ട് ഒരു സ്ട്രെയിറ്റ് ലൈൻ ഇത് കണ്ടോ, ഈ സ്ട്രെയിറ്റ് ലൈനിലൂടെ അതിനെ ഇങ്ങനെ റൊട്ടേറ്റ് ചെയ്യിക്കുക. അപ്പൊ ആ പോയിന്റിന്റെ പാത്താണ് നമ്മുടെ സൈക്ലോയിഡ് എന്ന് പറയുന്നത്. അപ്പൊ ഇതാണ് നമ്മുടെ സൈക്ലോയിഡിന്റെ ഒരു റൊട്ടേഷൻ എന്ന് പറയുന്നത്. ഇതാണ് സൈക്ലോയിഡ് ആണ്, റൈറ്റ്? So these type of curve is known as the cycloid, right? The equation for the cycloid is x is equal to a into theta minus sine theta, y equal to a into 1 minus cos theta. And this cycloid provides a solution to two famous problems. One is the Brachistone problem and next is the tautochrone problem. Brachistochrone problem and tautochrone problem. Brachistochrone problem means there is a find a curve along which this is a Brachistochrone problem. Find a curve along which a moving particle will slide from a point A to another point B in shortest time, not directly beneath A. A is here, B is here, not beneath A. This is A. Movement of from A to B, right? This is actually, I had to renew that. That is I'm replacing this here B. This is B. This is A. Okay. Then through this cycloid movement, cycloid path, this A, the point, suppose a person is a point is here. Okay, ball is here. Ball is here. Ball is falling through these. When this ball is falling through these curve, then that will reach to B with a shorter time. Okay, so this path is actually cycloid path. This is a solution of this Brachistochrone problem, right? Similarly, the tautochrone problem means find a curve having the property that it takes same time for a particle to slide from the bottom of the curve, no matter where the particle is placed on the curve. So this is a path here. Okay. It's actually a cycloid path. cycloid path. This is a point. I'm placing, suppose I'm placing ball is here. Suppose I'm placing ball is here. Then ഈ ബോൾ എവിടെ വെച്ച് കഴിഞ്ഞാലും ഈ ബോൾ ഏത് കേർവിലാണോ ഫൈൻഡ് എ കേർവ് ഹാവിംഗ് ദ പ്രോപ്പർട്ടി ദാറ്റ് ഏത് പ്രോപ്പർട്ടി ഇറ്റ് ടേക്സ് സെയിം ടൈം ഫോർ എ പാർട്ടിക്കിൾ ടു സ്ലൈഡ് ടു ദ ബോട്ടം ഓഫ് ദ കേർവ് നോ മാറ്റർ വെർ ദ പാർട്ടിക്കിൾ ഈസ് പ്ലേസ്ഡ് ഓൺ ദ കേർവ് എവിടെയാണ് അത് പ്ലേസ് ചെയ്തതെന്നുള്ള മാറ്റർ അല്ല എവിടെ വെച്ച് കഴിഞ്ഞാലും അത് സെയിം ടൈമിൽ ഇവിടെ തിരിച്ചെത്തണം ഓക്കെ അപ്പൊ ഇതില് സൈക്ലോയിഡിൽ വെച്ച് കഴിഞ്ഞാലാണ് ഇതിന്റെ സൊല്യൂഷൻ എന്ന് പറഞ്ഞാൽ ദ കർവ് ഈസ് സൈക്ലോയിഡ് സൈക്ലോയിഡിൽ എവിടെ വെച്ച് കഴിഞ്ഞ് കഴിഞ്ഞാലും മുകളിൽ എവിടെ പ്ലേസ് ചെയ്ത് കഴിഞ്ഞാലും ഇവിടെ റീച്ച് ചെയ്യുന്നത് സെയിം ടൈമിലായിരിക്കും അവിടെ റീച്ച് ചെയ്യുക ഓക്കെ ദിസ് ആർ ദ സൊല്യൂഷൻ ആക്ച്വലി right. Next is, and also one more we have to notice that what path minimizes the total travel time in Brackestown Chrome? And this one, the cycloid. The answer is cycloid path. The path is the answer for these two curves, two problems. This is a cycloid path. Okay. Next is we have to check the next portion in this. Calculus of the parametric equation. Calculus of parametric equation. Calculus of parametric equation. Calculus of parametric equation. This is a chapter 10.3 in this. Okay, in this chapter, first we are going to deal with what is the tangent lines. First one is the tangent lines to the curves defined by parametric equation. Defined by parametric equation. Defined by parametric equation. Okay, the tangent line defined by this is we know that the tangent line is any point is dy by dx, right? So here this is dy by dt divided by dx by dt. Where this provided that dx by dt is not equal to 0. This is the formula dy by dx is equal to dy by dt divided by dx by dt. We can do one example in this corresponding to this. X is equal to sec t, y equal to tan t, y equal to tan t minus pi by 2 less than t less than pi by 2. X is equal to sec t, y equal to tan t minus pi by 2 less than t less than pi by 2. In this we have to find out what is dx by dt. Dx by dt is derivative of sec t, that is sec t into tan t. Derivative of that is dy by dt. Dy by dt is equal to sec squared. Then dy by dx is equal to dy by dt, that is sec square t divided by sec t into tan t, which implies that is sec t divided by tan t, which is equal to 1 by cos t into that is sin by cos, that is cos t by sin t which is this get cancelled, and this is equal to cosec t, and this is dy by dx. dy by dx is equal to cosec t, and this is find the tangent at the point. The question is t equal to pi by 4. Then dy by dx at the point t equal to pi by 4 is equal to cosec pi by 4, which is equal to root 2. And what is the tangent line here? Y minus y naught equal to m into x minus x naught at this point. That is y naught. Y naught is equal to, at t equal to pi by 4, y naught equal to 1, x naught is equal to, x naught equal to, y naught equal to 1, and x naught is equal to root 2. So the equation is given by y minus 1 equal to m is equal to root 2 into x minus root 2. This is the tangent line, tangent equation for these curve. Okay, and this is a rule in this. Next we have to notice that next portion is where we have to deal with the horizontal and vertical, horizontal and vertical tangents, horizontal and vertical tangents. Horizontal tangent means, what is that? Horizontal tangent means this is a curve. Okay, and a horizontal tangent at this point have horizontal tangent. Suppose this is a curve. At this point, this curve has vertical tangent, right? And when does a curve has a horizontal and vertical tangents, right? Suppose the curve x is equal to f of t, y equal to g of t, where t is in the domain minus infinity, less than t, less than infinity, right? And in this curve, a curve C is represented by